when I have a log and I need to find the other side of the expression. So converting to exponential. That's just wrong, isn't it? Exponential. And the other way around, vice versa. Obviously, you need to be able to convert in both directions, right? Basically, if I give you this side right here, you need to find that side. If I give you this side right here, you need to find that side. Yes? So.
And what? What is it?
Vice versa.
Vice versa. I don't write the whole thing again, right? Converting to logarithmic form from exponential. That's just English. Nobody likes English. Right? It's 243. Let's say I have the expression log base 3 of 243 is equals to x. Right here. This is clearly a log, yes? Or anybody happens to know what the answer to this right here is? Log base 3 of 243. It actually is helpful if I can write this in exponential form. It actually is helpful. This is how I like to write in exponential form. I know since I write exponential form, I'm not going to need the word log, right? Because log means inverse exponential form, right? And you simply take the base to the other side. 243 is equal to 3 to the x power. Drop the log and take the base to the other side. I'm going to say this like 500 times today. Drop the log and take the base to the other side. And that's all you need to do to convert to exponential form. Okay? Now that I have converted this to exponential form, isn't this an equation I can solve from what we've been doing? Aren't both of these from the same base family?
Yes.
3 to what power is 243?
Wow.
3 to the 0, 3 to the 1, 3 squared, 3 cubed, 3 to the 4th, 3 to the 5, 243. So 3 to the 5 equals 3 to the x. X is 5. So not only is it important to be able to convert from one form to the other, it's also useful actually doing stuff. Yes? So, to convert from logarithmic form to exponential form, convert to exponential form, you drop the
Log.
base, drop the log, right, I'm wrong. And what do you do with the base?
Take it to the other
You
side.
take the base to the other side. And that converts us to logarithmic exponential form. So, how you convert the other way? Just do the reverse, right? Take the base over and add the word log in. So, let's say I have log base b of z, and that's equals to 12. How would I write this in exponential form?
B for D12.
Yeah. Drop the log, take the base to the other side, you get z is equals to b to the 12th power. I have no idea what z's, I have no idea what b's, but that's okay. Yes? One more? So let's say I have log base 2 of h equals m. Write this in exponential form. Should take you longer to write the problem down than to solve it. Drop the log, take the base to the other side. So h is 2 to the m power. So obviously, if I ask you to go the other way, and I give you a log and ask you to write an exponential form, that's pretty straightforward, right? Do the same thing but in reverse. So if I have 3 is equals to k to the p power, write this in logarithmic form. Converts to logs.
And
adding the keyword log, the base is k of 3 equals p. And if you have a hard time, just transfer it back. If it transfers back and gives you this, then it's right, right? Drop the log, k comes over here, yeah, that's right. Right? So if you have a hard time going from one to the other, just double check, see if it's right. So in other words, learn one way really well, and then the other way you kind of figure it out. No? No?
Is that a K?
Yes, that's a pre-K. Pre-K. Okay, no it's not, but that's alright. Exponentials have 5 basic properties, right? Exponentials have 5 basic properties, correct? I'm actually going to focus on 2 of them for now, and then we'll come back to the rest later when we get to the graphs. Exponentials have a domain from negative infinity to infinity, a range from 0 to infinity. It was increasing. Had a y-intercept of 0, 1, and it had a horizontal asymptote of y equals 0. Yes? The logarithms, which are the inverse functions, are what you get when you switch the x and y values, yes? Remember the inverse function, the most basic definition of an inverse function is take all the x values, take all the y values and simply switch them, right? And so all you're going to have is all the x's and y's are going to do what? Switch places, right? And so what you will first find is that the domain and the range, the x's and the y's are going to switch places. And so your new domain will be from 0 to infinity, and your new range will be all real numbers. The increasing actually stays the same. You'll see why a little bit later. Instead of having a y-intercept, we will now have an x-intercept of 1, 0. And instead of having a horizontal asymptote, we will now have a vertical asymptote at x equals 0. Does that make sense to you? Inverse functions. We're rotating all the pieces, all the x's and y's are switching places. Bye-bye, x. Hello, y. No? No. This in particular is very crucial to understand in logarithms, this one in particular. So we'll look at it a little bit more closely, right here. So if I take log of any base of the number 0, what does this tell me the answer is going to be if I take log of 0?
1.
No. What does a parentheses mean? See, I have a parentheses on x equaling 0. I have a parentheses right here on x equals 0. What does a parentheses mean?
It cannot be 0.
0, it cannot be 0. This is undefined. No solution right here. If I try to take the log of a negative number, log base a of a negative number. Oh, is this pronounced pound or is this pronounced hashtag?
Pound.
Depends how old you are. Well, apparently you're in the middle, huh? So it's switching over. It used to be pound. Apparently now it's hashtag. Yes? I cannot plug, logarithms can only take numbers from 0 to, well, numbers that are greater than 0, right? So you plug in 0 in the log, you don't get an answer. If you plug in a negative value into a log, you do not get an answer, okay? That's very important to remember, especially when you get to solving logarithmic equations. What's about this? Log of any base of the number 1. What is log of 1? Let's put my little base A back here. What's log of 1? What's log of 1? When you plug in 1 into a logarithm, the answer is? 0. The answer is 0. See how these three properties right here come from just the fact that these two things switch places? Now these next three properties are new properties, but properties that you need to know. If I take log base A of A, the answer is going to be 1. If I take log base A of A to the nth power, the answer is going to be n. Can you tell me why?
To the end.
The A's would cancel, right?
Logarithms, I'm going to finish writing because you know, let me hear this one. This is maybe the most important property of the whole thing. Logarithms and exponential functions are inverses of each other. Remember we did that whole thing where you take a function and plug in its inverse, the answer is always the same? Your answer is always a single number x?
Yes.
Same thing right here. This log right here and this exponential, they actually cancel each other out. And the answer I'm left with is just, and that's the answer. Log and an exponential, they always cancel each other out. So if I write this in the reverse format, if I write it as a raised to the log base a of n, what's the answer to all of this, right? The answer is simply n. Log and exponential functions are inverses of each other. They always cancel each other out. These properties, you need to memorize them, because on the test and on the homework, there'll be several logs you'll have to evaluate, and you won't have a calculator. And so you might get an example like this. Let's say I have log base 7 of 1. What is log base 7 of 1 equal to? 0. Yes? Clap, clap, it's the letter of the day. Clap, clap. Let's say I have log base 100 of negative 100. What's that equal to?
It's undefined,
It
right?
is not 1.
It's undefined, right?
Undefined or no solution. Undefined. Why you say? The negative. Yeah, the negative's killing you. If I had this, if I had log of base 99 of 99, then the answer is 1. I am paused. Are there any questions? Can a log be negative? Can a log give you a negative answer? Let's say I have log base 3 of 3 to the 5th power. Let's make it 4th power. I'm not life easy. 3 to the 4th power. What's this equal to?
4, right?
That's equal to 4. Everybody following along? Understand why this is 4?
Yes.
Because they cancel out, right? The 3 and the log cancel out, so the answer is cuatro, right?
See.
I see. I see what you did there. What's about this? Let's say I have log base 3 of 81. What's log base 3 of 81 equal to? 4. What's log base 3 of 81 equal to?
4.
3 to the 4th power?
81.
81. What's 81? 3 to the fourth power. So can't I just simply, instead of looking this right here, do this right here, log base 3 of 3 to the 4th power? Can I just do that?
Yeah.
So the answer is?
4.
The answer is 4. I am paused right there. Any questions so far? Now, most students actually have an issue with this problem. So I often suggest a different way of getting to the same answer. So let's say I have log base 3, not base 3, log base 5 of 125. Do you happen to know what the answer to this is? Well, if you're like me, you know it's 100% sure. So you can say, well, okay, I don't know what the answer is, but I know it's going to be a number, right? It's not no solution, right? It's not 0, it's not negative, right?
Right.
Right? So I set it equal to x, and then I simply convert to exponential form. When I convert to exponential form, what do I get?
125 equals 5 to the x.
Drop the log, take the base. I thought you say it's like 500 times today. Drop the log and take the base to the other side. And so it tells me that 125 is equal to 5 to the x power. Now, are 5 and 125 the same base?
No.
Can I cancel them out?
No.
But are they in the same base family?
Yes.
Yes. 5 to what power is 125?
30.
3. So 5 cubed is equal to 5 to the x power. So that tells me x is
30.
3. So therefore this whole thing is equal to 3. I guess I can do it this way. Questions here, kind of people? Okay, go ahead and try these two for me, please. So let's say I have log base 4 of the number I need is 32. I want to know what that's equal to, and I have log base 3 of 1 over 9, and then I have log base 5 of the square root of 125. Okay, 3 problems right here. 3 logarithms that I don't know the answer to. And I don't have a calculator. No! No! Any questions out there? Waving your hand to the left and to the right. Like I said, most of this stuff right here is not that bad, but I mean, you've never seen this before, have you? Probably, hopefully, possibly. So yeah, it's going to take you a while to master it. You know, understanding, learning, and mastering are all different processes. That's it. You ready to see the answer? Is that what you're saying?
No.
Equal to x. All of them.
Oh, equals to
all
x.
of them system stuff like equal to x. Because x means an unknown, right? An unknown that you're about to find, right? So can a log be negative?
Yes.
Yes.
Yes, it can. Yeah.
Understand?
Okay. There is none.
That's disrespectful. Okay, so, I will do this.
Okay, so for number 1, I set it equal to x. And after setting equal to x, I have to convert, I'm out of space, so okay, I'll have to do it over here. I convert to exponential form, right? So I take the 4 over, so I get 32 is equals to 4 raised to the x power. Are the bases the same? Are they from the same base family? This right here is 2 to the 5th power. This right here is 2 squared. And so 2 to the 5th is equals 2 to the 2x. I can say bye-bye base. Bye-bye loneliness. Hello, correct answer. Think I'm going to cry. No, no, no. No. Okay, the next one right here, I have log, the base is 3 of 1 over 9, that's equals to x. So therefore, 1 over 9 is equals to 3 to the x power. I have a fraction, so I can reciprocate it and make the power negative. So I have 9 to the negative 1 is equals to 3 to the x. Again, not the same base, but the same base family. So I can write 9 as 3 squared. Negative 1 equals 3 to the x. So that's negative 2, right? So x equals negative 2. After I cancel the base. Questions? Yes?
On the test, if you skip the middle part, do you count off of that?
If I can understand what you're doing, no. But if I can't understand what happened, then yeah. We're going to have problems. So log base 5 of the square root of 125 is x. So the square root of 125 is equals to 5 to the x power, right? Square roots means what kind of power? Fractional powers, correct? Whenever you have a radical, you have a fractional power. So this is actually 125 raised to the 1/2 power. Right? Now I got the same base on each side. No, I don't. But I have the same base. Family. Don't you just love family? Family. 5 to the 3rd power raised to the 1/2 is equals to 5 to the x. What is 3 times a half?
3 halves.
That's 3 halves. Are better than 1? No. 5 to the 3 halves is equals to 5 to the x. And so the answer is? So we have seen that the answer can be a fraction, so a logarithm. The answer can be negative, right? That's going to be anything. The issue is the number we're plugging in can be bad. We can't plug in a negative number into a logarithm. We cannot plug in 0 into another logarithm because the domain is numbers that are larger than 0. Okay. But logarithms do give you both positive and negative numbers. I am paused right there. Any questions? Okay, there are 2 special logs that are out there in the universe.
Who came up with logarithms?
There was a need for the inverse of exponential functions. Because a lot of times what you need to know what the power was and not what the number was. So if I tell you, for instance, 50 is equals to 100 raised to some power, I need to know what that power is, right? And so what I need is the log to get to the answer. If I take this and I convert it to logarithmic form, I could then get the answer, right? I take the base to the other side and I add in the keyword log. I will have log of 100 of 50 equals x. And then this right here is an expression. When you get the calculus, they'll show you how to get this. There's actually a way of figuring out by just plugging the number 50 into an expression. Calculus, they'll show you how, and then table x. sometimes you need to know the path. The problem is you just don't have experience with logs. Logs are pretty easy. It's just that you don't get experience. That's not your fault, you know. But it is now your responsibility to learn. Hey, what's that? Right. The common and the natural logs. The common and the natural logs. The most commonly used logs are logs of base 10 and logs of base E. Remember what E was?
Yeah.
The natural number? 2.71828, blah, 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 going on forever?
Y'all.
Y'all.